This is Deepak Kumar Gupta. I'm working as a software engineer. So today I'm going to give you a brief introductory session for MongoDB. So my voice is clear right now? Hello. MongoDB first thing, and why we need it and when it has evolved. So MongoDB comes in the market on around 2005. So what happened, why MongoDB came into the market or came into the picture, why we need MongoDB, whereas we already have such kind of database, DB2, Oracle, MySQL and all these things. So why we need MongoDB? So what happened when a big company has a lot of huge database? So suppose, say, any XYZ company, or take an example for Facebook, suppose. Facebook is already having a huge database customer care. Okay, so they have plenty of customers who are using their website Facebook. So on the same time, we have to maintain their database, like their profile for different things. So what happened earlier, they were using a normal RDBMS system. So but later on, down the line, they realized that their RDBMS system is not that good to fetch the query very instantly when the user send a request. So what happened, suppose you have a profile. So one table would contain your username, password information, one contain your address, one contain the photo that you have sent, one contain the video that you have been uploading day by day. So once you need all these things on your first web page, so see or think about the query that will go and check for all the tables and fetch the relevant data and so on the web page. So that would require some time, some manipulation time or some retrieving time, going to network here and there and collecting the data for you. So that is not acceptable by the user, because they want to be fetch the data there and there. Okay. So that is how the MongoDB comes in the picture. Why we need tables? Do one thing, just store all the relevant information for the user in one single table, or for now you just say table, but in the MongoDB it would not be a table, it will be treated as a document. So they introduced the concept of MongoDB. So MongoDB is basically a document-based database system. So what do you mean by document-based database system? The document is nothing but it's a simple JSON format file that will have all the information. Suppose you have your username, your password, your photos, your videos, your XML tag, your post, every single thing what you have seen in this world can be accommodated in one single row that is called a document, and that document is going to be stored in the MongoDB database. So suppose whenever you are saying a particular request to the server, see, I want to see this particular profile, so what it will go, instead of going all the tables, it will simply go and find one document and show all the relevant information to one web page. So that will make your job very easy, rather than going on multiple tables, writing some join queries, finding the relevant data and so on the web page. Instead of that, you have to just find one MongoDB document. That's it. That will do every single thing what you want. So this is what all about for MongoDB document. And the most important thing is an open source software. It has been written in C++. It's a high performance, as I explained you. The second most important thing with the MongoDB is a schema free. So the person who knows RDBMS, they very well aware about the schema. So what does the schema means? So for software industry, say whenever we bid for a particular project, we have a specification, or you can say the document that has all the relevant information that is going to be built or as a part of your project. So for that, we just do normalization, we decide our tables, we decide the form of the tables, linking of the tables, field of the table. So that is a huge work for architect who develop a new software. So they have to design the schema, a proper schema that is going to be used for that particular project. And suppose later on, if client is coming saying that I need to want a little bit change or little bit enhancement for that particular project, that is going to be a pain for a software industry, because it will take a huge time to design a new schema, think about it, what is all the positive points, what are all the negative points, and a lot of works involvement. And of course, cost would be a factor for that. So MongoDB has introduced a schema free. That means there would not be any schema. So suppose you say a patient, employees table where employee name is there, employee ID is there, and employee salary is there. So suppose you are working on a very small project that required these three fields. But down the line, you feel that, no, I want employee photo as well, that is going to be added in that particular project. So for adding a particular photo, you need a new column in the employee table so that you can store your image over there. But that required all the changes in your existing database system, auditing the table, adding the new field, deployment. If you have written such queries that are only fetching those 3 rows, then you have to update the queries as well. So here in MongoDB, you need not to be worried about it. Your one document contains your employee name, your employee ID, and your employee salary. And a very second document, you can add a new document audit that will store your image. So that is schema free. No need to be worried about the schema. Okay, and it is a document oriented database system, as I have explained you earlier. Now what we are going to talk in this particular slide or in this particular session is what is MongoDB, how do we perform queries in a MongoDB, what do we mean by replication, what is serving, what others features, a little bit code sample about the MongoDB, how do we write the JSON format. And the performance wise is the most important things nowadays, because if you are involving with the database, you have to think about the factor, how much time it is taking to retrieve or to execute one query when your system is specifically is a network based system. So you have a multiple server on a different location. So when you run a particular query, where exactly it execute, how much time it is taking to fetch the data, whether the data is really relevant or not, the your queries tuning and all those things. And the last topic would be, how do you decide where to use MongoDB, when to use MongoDB, and how to use MongoDB. And the most important thing, why to use MongoDB. Okay, so we have already gone through the document oriented database system, so that is called JSON. So JSON is nothing but your JavaScript object notification. So this is what, when the MongoDB was initially developed, so they have to find one particular structure, how to save the database into how to save a particular document in the database. So for that they need a particular structure. They can go for the XML, they can go for your normal key value pairs, but they have decided to go for JSON, because JSON syntax is high level syntax, you can say, is very comfortable. You have just one tag that will be your value and key, that's it, nothing more than that. So you should be just take care for two things, your key and value pair, that's it, and the rest of the things will be taken care by your JSON object. So that is nothing but the JavaScript object notification. The second one is dynamic schema. As I have explained you earlier, is schema free. That means you can change your particular database schema at any single time. Whenever you think you have to be introduce some new fields or you have to be remove some fields, you can simply do that. Okay. Non-relational. So most of the people are a little bit confused. What is NoSQL? Why it is called NoSQL? Okay. So NoSQL is a category, that's it. And out of that category, MongoDB is one of the database that fall under the NoSQL. So how that NoSQL come into the picture? So SQL, you are well aware about the SQL. That means structured query language. So there are some things that cannot be just accessed by your SQL only. So we need something else. Okay, what else? That is schema free, your replication, your sorting. So that is outside of your SQL. So that is not only SQL. Okay, so that is how that NoSQL comes into the picture. Why the people start calling NoSQL? Because there are certain things that cannot be achieved by only SQL. Okay, got it? So that is why we call it as a NoSQL. And MongoDB is one of the database that fall under the category of NoSQL. Performance wise, as I have told you while explaining the history of MongoDB, that it is written in the C++. Okay, is a full index supporting. That means is really fast. Okay, think that if on the same time MongoDB is giving you these many things, okay, the fast accessing, schema free, all these things, on the same time we have to do a little bit transaction free things here in the MongoDB. So what do you say, like when to use MongoDB? So is not OLTP. Okay, OLTP means the person who are coming from the SQL background, they are well aware that SQL is very well known, has a rich set of SQL query that will support your OLTP transaction. OLTP is nothing but online transaction processing. Okay, so there and there it will process and update the database. So MongoDB doesn't support that way. Okay, it has their own implementation that we will be looking very thoroughly in upcoming sessions. Okay, for now you just take care for one thing, that MongoDB doesn't support your online transaction analysis. Okay, is not relational. It does not have any tables. It does not have any joins. Okay, because join takes some time to execute. You have a multiple tables where you have to keep joins and all these things. But on the same time, maybe some of you guys are thinking about why not joins. Okay, how you are going to be fetch the data. So that is how I have explained you in the initial phase, that it is a document. Means one document has all the relevant information, irrespective of your salary, irrespective of your address, irrespective of your photo, your videos. Only one document would be more than enough to handle or to keep these values. That means there is no need of join at all. Within one document you are finding every single thing. So that is how it's not relational. Okay, scalability is a very important factor. Suppose you are working in a project or you recently join a company. So suppose say any company, I'm just taking an example of TCS. TCS is working on Aadhaar card project. So in Aadhaar card project, there are a huge number of database tables are already maintaining by the TCS. But day by day, there are people who are keep registering for the Aadhaar card registration. Okay, so that is how the tables are growing dynamically, rapidly. Okay, so the scalability of that particular project are keep increasing. So how to maintain that? How to make sure your data is secure? So to making that one, you have a concept of replication and sorting in MongoDB. Replication is nothing but you have to write some small task that will be keep checking your database and writing the same database over a little bit of time latency in a next server. Okay, that is called replication. Sorting is nothing but keeping two same instance in a different location for a disaster recovery. Okay, suppose on one instance something went wrong and you lost all your data. On the same time, you have a sorting and a different network location that you can go simply and find your all the relevant data from there. That is called sorting. Hope I am clear. So these are an example for all the companies which are using MongoDB at the moment. Okay. And out of these, there are some other companies very well known like Disney, JP Morgan's are our biggest customer for MongoDB nowadays. So we have been talking about the document oriented. So how it look like exactly, how many number of fields it has, what exactly the tag and all these things it has. So you can simply see here one database. So it has one key and this is the value. So the title is considered as a key and this particular value, that means no SQL database internals, is a value. Then again we have a key and then we have a value, key value pair. So this is how exactly it works. So it does not have any kind of limitations. You can go within one document, another document inside that. So that is called inner document. Think about the same way that when you perform your SQLs or when you design your database. So I believe everyone has worked on some minor project. If the people are coming from the college background, they did their minor project in, definitely they need a tables. So think in that way, suppose this is one table that contains these many rows, okay, and there is another table. So here another table is coming with a normal document, that is inner document. So consider that as a different table. So now go back to the normal SQL and think if you want to fetch all these records and then together these records. So what you will do, you have to write one join. So that join will fetch these many your columns value and these many columns value. So here what I am saying, that instead of writing a join, I have declared as a inbuilt document. That means another document within another document. That's it. So that document can contain any kind of value, your tables, your features, your pictures, your videos. So there is no need for joinings. Okay. Am I clear, guys? Okay. So this is an outlook for your deep queries, SQL queries, how the SQL queries works. Okay. So you're well aware about the tuning and all these things, how that SQL queries works. On the same way, we have here the query format. Okay. So this is a predefined. DB is an instance of MongoDB. Okay, so we have a MongoDB that is called server and Mongo. These are the two different services. Whenever you run your MongoDB, your instance have two things running on the same time. That is, one is the MongoDB and the second is a Mongo. MongoDB is a server and Mongo is a cell. Okay. And within that cell you can run any of your JavaScript code. So on this, when you perform any kind of query within the Mongo cell, you have to write one instance that is called DB. So DB is nothing but database, and on that instance you have some defined method. So post is nothing but your collection name. Okay, db.collection.find. Okay, find is a method, dot post is a collection name. Collection is nothing but, for the time being, you treat collection as a table. Okay, so suppose you want to write one query from employee table to fetch all the data from employees table. So what you will write in the normal SQL, select all from table and then table name. And the same way we will use db.collectionname.find. That means it's equivalent to select all from your table name. So this is how you can correlate with your normal SQL to NoSQL. What it will do, it will give you all the rows. In a MongoDB term, it will give you all the document within that collection. So where document resides within a collection, where collection resides within a DB, that is MongoDB. Okay, so now the picture is clear. You have a database, you have a collection, you have a document, and within that document you have a row. So this is how the architecture of your MongoDB, very high level architecture. Okay, I'm not giving you right now the in-depth knowledge of your architecture, though that is what very important to understand when you storing your JSON object into the MongoDB. We'll discuss about in the next slides. So now this is the way we will find. So see, you write one where conditions. So where imply ID equals to 1 not 1. So that will give you only one particular row that have all the information for particular imply, that is 1 not 1. Okay. So same way we have a where clause here. Within the find method we have one key and then the value. So what you do in a where clause, you do the same thing. You give a condition where imply ID equals to XYZ. So you restricted your query with a one particular condition. The same way the MongoDB within find method, you can write one key value pair. It will find all the row with respect to that particular key value and give you that particular rows. Okay, and you have some aggregation, because what you do in a normal day-to-day life, you fetch your data from the database and then you do some normal operations on your database. You want to be project your particular DB queries in a human readable format or the presentable format, so that one can easily understand what do you mean by that. Suppose you want to retrieve all the employees which has salary greater than 10 lakh per year. This is what the information is all about. So your database has the raw information. Okay, you write your SQL query, some intelligent SQL query to form that data in a presentable manner. So that is how the aggregation frameworks comes into the picture. Same way, in a MongoDB we have a aggregation frameworks. Okay, that is this particular dollar less than or equals to. This is means. Okay, so that means you are now saying I want all the data that has the particular date less than or equals to today's date. Okay, so it will give you all the data. So this is kind of one of the very good example for your aggregation frameworks. Okay, and the very last example here is for to query a particular element that is within that document. So inner document, as I shown earlier. So this is one document and this is inner document. Suppose you want to do a query on this particular element. So how do you figure it out? So one document within other document is being queried in a MongoDB like db.collection.find, and then that particular outer document dot inner document and then the particular element value. Okay, it will give you that particular within document row. Okay, if not clear, do not worry about it. It's just simple inner document query fetching mechanism. That means if you have a document within another document and within that sub document, if you want to be retrieve any particular element, you have to use dot operator. That's it. As simple as it is. Use a dot operator on a collection dot sub collection and then the particular value. It will retrieve the relevant record for you. So now move to very basic, that is the CURD operation. So CURD is nothing but your create, read, update, the very basic operation. Okay, so let's take an example of your insert. how do you insert any particular row in a document. Okay, so we have an insert command for that one. So you will write dv.user.insert, okay, here, and then the particular key and then the value. This is the way you will simply insert it. Okay, so how it will look like in your normal SQL. Okay, this is the normal SQL. Insert into particular table. So user here is a table, wherever here user is a document collection. Okay, and that collection will contain these value, name as this, age as this. Okay, got it? So whenever you do a normal insert, a most important things happen here. In a normal SQL, you have a unique key that you always define for fast accessing of your data. So here in a MongoDB, you need not to be worried about it. MongoDB itself insert one ID document that has a unique values. Okay, and on the same time MongoDB gives you the opportunity to enter by your own. If you don't want to go with MongoDB, you can define your ID here as well. But here what it will do, it will simply insert, instead of these two records, it will insert three records. So one is your name and second one is your age. Along with that, you will have a one ID column. Okay, that will be the third column that is going to be inserted automatically in the MongoDB database. Got my point? If not, let me repeat it because it's a very important point. Whenever you do an insert in the MongoDB document or a collection, it will add one underscore ID field by its own. Okay, why its own? Because you know, whenever we insert something in our database, it must have something unique, though the document would be same. Suppose my name is Deepak, my age is 25. There could be another person with the same name Deepak, same age 25. So how do you bifurcate between these two elements? Until and unless you have something unique in your hand, you cannot bifurcate. So that is how that ID field is very important, and that is taken care by your MongoDB frameworks. It's internally. If you are not doing it, if you want to do it, well and good. You write your own ID. It will definitely accept it, and you will have your unique ID now within your collection, within your document. Okay, so that is all about the insert. There are a number of different use case for insert. How to insert it? Insert multiple rows all together, or you want to insert particular kind of within a range 100 element at a time. So those things comes into the different picture. Insert method has a different argument. So we will go and cover those into the later class. What about the update? Okay, this update is nothing but the same way you do update. You put one particular query clause with which particular column you want to update and what is the value. Okay, think about where the name is Deepak, update the age as 36. Okay, so you are giving a where clause here. Where clause is nothing but the condition. The same way MongoDB does expect you to tell what you want to update and what exactly the value you want to update. Okay, so suppose you have a column that has a name, that has a age. So now think about name as a value, give the value which particular name you want to update and with what value you want to update. So use a set parameter to update it. That's it. It's very similar to your SQL. If you have worked on the SQL, if you have a basic knowledge on the SQL, you can go ahead and start writing your MongoDB queries by your own for sure. Okay, so that is how it works. Now go to the scalability factor, or think about the thing that we have spoke in our very first slide, that is a schema-less. Okay, how do you think that is schemaless? So here is the third example of insert. Okay, here you are inserting the name, you are inserting the age, and now you realize that you need one more field, that is the email ID. So here you are feel free to add any new field for your email ID. Now if go ahead and write one query to retrieve the data. So see here one document has been inserted here with two values, name and age, and the same document has been inserted here again with one new field, that is email ID. Okay, so suppose if you are writing a query from select query, select all from the table where the name is Puvar. So it will be giving you the two records. One is having the name and age, the second one is having name, age and email ID. Okay, got it? But think about the normal SQL tables. You cannot insert until unless you go and update the structure of the table to add a new field, that is email address. So how many times you have to update it, queries and all these things, because it is not just one table. There would be a number of tables who are using the joins. But here within the MongoDB, you need not to be worried about it. Whenever you think you need some new attribute to be added in your project, go ahead and simply add it. MongoDB is more than happy to accept it without giving you any kind of proper limitations. Okay, there are no limitations. You can go ahead and add it. Now simply the last operation is a delete. Okay, you insert, you update, you select or you can say read, and then you delete. These are the four basic pillars you perform on day-to-day basis on your database, and this is how we require database. Okay, for updating, for reading, for deleting. Okay, so the deleting is nothing but delete from your database. Okay, so the same way you have a DB, again is the instance of your MongoDB, and then the collection is the name, then here the collection is user, and then remove. What do you want to remove? Remove all the rows which has age. LT stands for less than, okay, less than 30. So MongoDB will go ahead and find all those elements which has age is less than 30 within the user collection. The most important thing is here, MongoDB will not go outside of your user collection. It will only look for all these rows within the user collection only and simply remove that. Okay, so delete from particular table in your normal RDBMS word. If you write one query, delete from table, so you know that this delete is not going to be go behind your table. Okay, so within table only it will find and delete those records. The same way within that particular collection it will find and delete those rows. Am I clear, guys? Hope I'm clear now. So this is something why should we go for RDMS, okay, and say your MySQL to MongoDB. The same thing we have been just keep observing. Your schema free is open source, easily documentable, easily you can write any single thing in this database. Okay, so the same way, suppose you have worked on Oracle, so when you write your Java code or your any application, so you need something to communicate with your application and the database. So that layer is called driver. Okay, so when you are using your MongoDB for any of the project, your programming language could be Java, Ruby on Rails, Python, PHP, Node.js, or any single in-house language. You need something to communicate with MongoDB and your application layer. Application layer is nothing but your application code, your business logic. where you write your business logic. So communicating between your MongoDB and your business logic, you need something that is called driver. Okay, so MongoDB has already did a lot of work to provide your built-in Java API or built-in driver APIs. So you need not to be worried about. You simply go ahead on the MongoDB website and download the required driver. That would be the free of cost. Okay, so that part is taken care by MongoDB developers, okay, by Tanyan University. So you need not to be worried about it. So this is all about your drivers and library that you require for your application to be communicate with your database. So in the very initial slide, I told you we are going to be little bit discuss about the replication. So why replication? What is the use of replication? Why we need it? Okay, so you heard about your licensing when your company purchase one database from suppose Oracle. So for your application, you're in a company, you're using a 10G. That is the version for your Oracle. So when you purchase 10G from your Oracle, so what Oracle will do, simply it will give you all the rights or for the you're maintaining the database. So what happened, whenever you save your data in your database, so Oracle do the same replication, but they will need your company authorization on the same thing. So company will allow your Oracle to keep a same copy of the data on their own server. If something went wrong with your own company server, you will simply go and tell Oracle that, boss, I lost my all the database. Would you be please recover my all the data? So this is what is all about the licensing. Why we are giving you that huge amount to the Oracle? Okay, because they are having that value. They are adding the value in their licensing. This is why we purchase here these many costly database. Okay, so think about the MongoDB. MongoDB does the same thing, but in a different manner. MongoDB give you the option. So there are, let me give you the different two things. MongoDB has two parts. One is the application, one is the administration. So when the administration guys will install MongoDB on your servers, on your within the company premises servers, so what they will do, they will create the replications, okay, replication factors. So whenever you write something on your particular instance, so MongoDB done some daemon thread. That, what do you mean by daemon thread? Daemon thread is nothing but your small programs that always run beside your application. You are not aware, but some programs are running. Why those programs are running? To keep an eye on your data that is now inserting in one instance on a within particular certain time of period. It will just simply copy that complete data and write in another instance. So you have the same copy maintaining on two different servers. So if something went wrong on one particular instance, you can go ahead in a second instance and recover all data. So that is what is kind of replication, and that is the most important thing. Okay. So this is very outline of your replication. Okay. Sorting. So replication is a concept. Sorting is a basic thing, how you achieve it. Okay. So suppose you have a client here, and then you have a Mongo S. Mongo S is nothing but a cell, is again a component to which you communicate basically. So you have a client, that client is always communicate with Mongo S. That's it. There could be more than one instance of Mongo S on the same time, depend on your requirement. Okay, so you have a configuration servers that has the configuration or that has a definition basically where those instance has been kept by your MongoDB server. Okay, so your client will communicate with MongoS, MongoS will communicate here with MongoD, and MongoD will communicate with your Mongo. So these are the different components within your MongoDB. Okay, so we will discuss about it. There are approximate 12 components. Okay, those 12 components, out of those 12 components we have a Mongo, that is the Mongo cell, we have a Mongo S, you have a MongoD, that is the server. Okay, so your client is communicating with Mongo S, Mongo S is communicating with your MongoD, and this is your MongoDB configuration server settings. Okay, am I clear, guys? If not, need not to be worried about it. This is something goes for administrator part. Okay, but being a developer, we should know what is all their internal, how it works. Okay, so I'm just giving you a particular overview of how that exactly works. Okay, if not, then we have a particular completely dedicated session for your starting. So this is another some cool features for your MongoDB that we are going to be cover in depth on further class, but little bit and very overview, large overview on GridFS or other components. So GridFS is nothing but a tool that MongoDB has provided for storing your data, because everything has some limitations. On the same way, JSON do have some limitations. JSON is nothing but the document that we save in a MongoDB. So JSON has some limitations, like these many bytes it can save within one document. So suppose now you might think about in that way. In our RDBMS, we have a different tables. We can save our relevant particular row without thinking of the space. If you have really physical space, then you can save n number TB or in a data in a GB or TB or anything. But here, as I told, JSON has some limitation. So suppose if your data is going beyond that limitation, so my data is going to be corrupt. This is the question. Of course, that is going to be corrupt because JSON exceeded now the limit. So what to do? How to make sure my data is persist in a safe format? Okay. Otherwise, my client will not come to me and by MongoDB. Okay, so that is how the GridFS come into the picture. So GridFS is nothing but a tool that give you the assurity that suppose if your MongoDB JSON document length is going to be beyond that particular limit, it makes sure that it will break there and start writing in a new document, new JSON document, and create one link between those two JSON documents. Okay, so this is nothing but your LinkedIn. Okay, so you linked for one JSON document with another JSON document, and that is all taken care by your MongoDB. Okay, you need not to be worried about it. Am I clear, guys, for what is GridFS? Okay, that is used for scale in and scale out too. Now move to MapReduce. So how MapReduce works? So MapReduce is two things, like one is map and reduce. What is again MapReduce? Everything start for what, okay, what, why and when. That's the most important things. Until and unless you know why, what, when, how, you need not to be worried about it, okay? Because how that MapReduce works, you must be aware of. Nowadays big data is in a very hugely demanding in the market. So big data is what? Okay, itself its name is very clear. What is big data? Big data is means that is the application which is really handling something very huge. Okay, let me give you a very interesting one example for this MongoDB. Okay, so in California, one student, like in a particular university, they asked the student to work on some dynamic project, okay, with the help of MongoDB, and that really help in some normal social activities. So their students pick one good example for their roads, okay. Wherever the jerk is there, speed breaker is there, they should know, okay, how to maintain all these things. So that project is basically owned by their government to fill the jerks in the road, okay. So how that is going to be possible with the help of MongoDB? So what those guys did is they choose an MongoDB as a database, backend database that will store all kind of information. Okay, they develop one mobile application and launch that particular mobile application to every single person who lives in that country, and they request those guys to just on their mobile devices wherever they go. Their application is enough mature or enough intelligent to bifurcate between a jerk and a speed breaker jerk. Okay, so are you getting my point? Suppose you are riding a bike, okay, you are going and suddenly you come across a jerk in a road, okay. So that application will measure with the help of Google Map what kind of density that jerk has, where is the exact location, the latitude, longitude of that particular jerk, and it will send that particular signal to the server, and then server will encapsulate that Google Map, the density of jerk and all these things, and store into the MongoDB. Okay, so think about the way every day all the citizens of that country is going here and there and finding the jerks, okay, without any resources, without giving a huge amount for hiring some people. Okay, your normal guys are doing the same things, and down the lines they collected all their data, and okay, and then they start writing some smart program to find out where exactly those jerks is. Okay, to writing that program is called MapReduce. Okay, getting my point? Now you're able to correlate your MongoDB with MapReduce. Okay, am I clear, guys? So you have a data. The first thing you need to worry about the data on what you are going to be analyze. Sorry, guys. So first you collected the data from all different locations for your global, for your particular country. Now you have a data. Now you write your own MapReduce programs. So one map means you are writing the code to fetch the relevant data, whatever the relevant data. You for this application, your relevant data would be your location, longitude, and latitude. That is the most important factor. Okay, and maybe your Google Map actual map, so that you can imagine that one. These two factors. So you will be writing one map program for fetching that data from MongoDB, and then you are writing to reduce it. Reduce means you are writing your code to collect for this particular location, say for particular zone A, how many jerks are there, on which location. So you will be preparing one team that will be dedicated for zone 1. So this is how MapReduce works. There could be other use cases, okay, that we will going to be discussed next time. What are other use cases where MongoDB fit it? Okay. On the same pace, MongoDB has a rich indexing. Okay, in the initial slide I told you, very rich indexing that even can't supported by Oracle nowadays. Okay, that has a MongoDB has that much capability. Okay, so geo specifically indexial. Okay, what does it means? Like whenever you have to be save your object in 2D or 3D, you need complete X, Y, and Z coordinate. So that kind of facility has been given by MongoDB. You can save your 2D, 3D indexes as well. Okay, so that is a very good example of your rich indexing has been given by MongoDB. Here is an example. Okay, suppose you have a 1 lakh of indexing queries in your database, and here are some different average, median, okay, different slots. So now consider this is your MongoDB. It takes 0.00025. CouchDB is another kind of NoSQL. There are certain Couch, MongoDB, Cassandra, okay, and here is your MySQL, normal traditional database, relational database. It taking 0.00199, okay. So see the guys difference between your execution because of the indexing, whereas our normal RDBMS systems take time on indexing because they have to go through all the indexing. Wherever MongoDB, if you are using the index, that means it is giving your fast output. The query performance time will be increased. The query tuning is very handy. Okay. Here another chart for your SQL and MongoDB time. How much time MongoDB takes, how much time SQL takes. See here guys, this red line shows SQL, and believe me guys, really believe me, even I work on some of the project here where simple synchronization query take 180 minutes to synchronize some table. You are just simply sitting idle on your machine waiting for the synchronization query to become complete so that you can continue your work. Think about 180 minutes for normal production environment. When your project goes live, just imagine the data, and suppose by God if you need to run one query for synchronization, how much time it will take. It may take 3 days as well. Guys, believe me, for the real projects that has a huge data, for maintenance kind of time, it takes really huge time. Okay, so see the time here. MongoDB is taking just like negotiable time. Okay, that can be tolerated very easily. So let's move further. This is something code based. So let's not go on the code base now. Okay, because this is need a little more closer picture to your MongoDB different components. We have a different 12 components in our MongoDB. We will go one by one those and try to understand where to use and how to use those ones. The most important thing to understand when to use MongoDB, that we will cover. Okay, these are some use of your MongoDB and some drawback. Of course, everything in the world has some good point, some drawback. If you are using MongoDB, you are coming with some drawback like a little bit time latency. Okay, let me give you another example for time latency that definitely I can bet every one of you come across for sure. Everyone has a Facebook account for sure. Okay, so what happened? Maybe you have noticed sometimes you are using your Facebook on your laptop, and another time you are using the Facebook on your mobile application. So what happened when you open that same Facebook page on your mobile? You see some different content over your wall. On the same time, if you go and open the same Facebook page on your laptop, you have a different content. What is that different content? Maybe one of your friend uploaded some picture that is not visible on your mobile, but that is visible on your laptop, and you can see only 30-second delay. If you refresh that one again on your mobile application, it will show. So that is kind of a delay. Okay, why that delay is there? That is because of maybe your mobile application is connecting to a different server for your Facebook, and your PC is connecting to different server of your Facebook. Okay, so here guys comes the concept of replication. Okay, the time latency. So suppose MongoDB, the write operation is for a particular instance is there and there. So for one server, just try to visualize that guys. In one server you uploaded the pictures, for there is a daemon thread is running on that particular server. That daemon thread is reading all those photos and taking some time to write in a different server. That is called synchronization. That thread is doing the synchronization among two servers. But where as you are connecting with your mobile in a different server, that does not have those pictures written yet in that MongoDB. That's the reason you are not able to see on your mobile application. Am I clear guys? Now able to think about it? As soon as you refresh your mobile Facebook page, you have access on that one. So that is a very little time discrepancies. Okay, that is acceptable, because suppose if I go to Facebook, say I'm giving you these many kind of benefits, can you tolerate a very negotiable time with your users? Facebook says yes. Okay, one guys can see photo from other friend 1 second before, that is acceptable, no harm for that. Okay, because we are giving you such a good vast rich set of other features. So please negotiate with this one. Okay, I'm not saying that your data is delay by 1 hour or 2 hours. This delay would be in a nanosecond. Okay, will be in a nanosecond, that's it. So there would not be a problem. So think about that guys. I'm not saying that MongoDB is a total replacement of your RDBMS. Okay, make it guys, try to understand this point very clearly. MongoDB doesn't say that I'm the replication, okay, for your RDBMS system, because that is not the replacement. Basically your normal traditional database has their own rich query set that has a OLTP locking mechanism that will be really useful for your online real-time transaction for your banking. Okay, but whereas MongoDB comes in the picture for your analytical purpose. Offline data analytics is the very huge demanding in the market now. So what happened, they collect the data, then they start doing some analytics on that data, okay, to understand what kind of output it would be. So those kind of things would be taken care for MongoDB. Am I guys clear very when to use MongoDB and how to use MongoDB, and when the RDBMS comes into the picture? Okay, you have to be very clear about these things. Okay, but the point, if you very well aware about the rich functionality of MongoDB, then I am 100% sure then you will think about by your own where MongoDB is going to be fit into the real world. Okay, thank you guys.